In this video, we are interested in demonstrating the altitude construction for a triangle, where the altitude is defined as a line that connects an end vertice with its opposite segment by a line that runs perpendicularly to that segment. In order to do this, we're actually going to demonstrate it for two triangles. First, the acute triangle that we have here, as well as an obtuse triangle, where when you look at the obtuse triangle, the altitude actually physically isn't in the triangle. Okay? So in order to do this, we're actually going to make use of the perpendicular bisector construction because we want a perpendicular line. To do this, we want A, as if it were dropped down here, to be the midsegment between 2 points which we don't have listed here. Okay? To do that, we want them the same distance away from A, so we're going to use our compass and draw a circle, or at least portions of a circle, to intersect those lines. Okay? So we now have 2 points on this line, points D and E, that if we bisect will make a perpendicular bisector that runs through A. So we use our normal construction here. We draw circles, partial circles, that are slightly larger than where we think the midpoint is going to be. I think I drew one too short, so we're going to make another one here. Okay, one up there. And we are going to make the intersection at the other point. Okay. So we connect these lines, these intersections. Okay. We have one here and one down here. Okay. And then we draw our line through, and then we note that we have a line that is both perpendicular to our original line and passes through the point A. This is the altitude through A. Now, just like the median example before, you have 3 vertices, so you can draw 3 altitudes. It does not matter which one you do if you're calculating, say, the area of the triangle. You just need to know the base times the altitude over 2. You can choose this base and its corresponding altitude over 2 as well, if you want to define, say, the area of the triangle in that fashion. Okay? Either one will work. So this was for an acute triangle. Let's take a quick look at an obtuse triangle given here. Okay. So we do the exact same process. We have our point at A. We just want to create 2 points on that line. It should be equal distant away from A. I'm going to call them again points D and E. We want to bisect segment DE. So we're actually going to use a slightly shorter one. Okay. That's part of our circle, and the other part of our circle. We now have our intersection points, and all we do is go straight up through those 2 intersection points through point A, perpendicular to our original line. We have now constructed the altitude of the obtuse triangle. Notice that the altitude itself is physically outside the triangle. And that will always be true for an obtuse triangle. You will always have that condition in 2 of the sides. The third side, the one opposite to the large angle, will actually be still inside the triangle. Okay. For a right triangle, even though we're not going to demonstrate it, one of the legs itself is the altitude for a given triangle.